Well, good afternoon. I'm going to go over a couple things here. Has to do with composites. So I was going to do some experimentation and make a couple wheel pants with some different formulas. Try to sort some things out and make a couple wheel pants. So I'll start off here with some PVA. I got to get some PVA in these molds, or just one of them. So I think I got enough in this jar, barely. One of the things I do with PVA, I actually keep it in this jar. And it's all stainless steel components. It's a Badger. See if I can get some more PVA down here. And if you use it every day, it's not any big deal, but what I do on this little gun, I've got these little vacuum stoppers. You get them in automotive stores, and I fill this thing with Windex and I keep it capped. That way it keeps the tip from drying out. Usually if these things clog up, it's usually in the tip right up in here. But that helps. I mean, this thing will go for weeks or a month, you know, with that cap on it. So I spray this PVA right out of the jug. Try to get to where there's no contaminants in it here. Some people thin it. I'll spray it right out of the jug. Works really well. A gallon of this will last you forever if you're in the hobby. Let's see if I can get this last mold sprayed. The compressor might kick on here. I'll unplug it, that way it won't come on. Okay. Let me adjust my gun. That's all there is to it. You could use a bigger gun. I like the small guns that gets into tight spots. So I'll put a little Windex here on the tip of this gun. Close down the needle. And then I'll put a little Windex in the cap. That's all it takes. Alright, one of the things, you want to speed up the process here. Just take a monocoat gun. Dry this PVA out a little bit. So the PVA will go from shiny to sort of a dull shiny. Just test it out on the flange here, make sure it's dry. Sometimes on these molds and you spray them, you might have a puddle in the corner, it's still wet. And you want to make sure it's completely dry. There's a little bit of a run in a couple of these, but it'll shrink down. It should be alright. These are going to be painted anyway. Normally I'll put a gel coat in a mold and then I'll put the cloth in after that. I think with these I'm going to go ahead and just lay the cloth in there. This cloth is about a 1.5 ounce, 2 ounce cloth. So I cool it off, switch the heater off. Alright, so next thing I got to do is cut some of this fabric up. The best way to cut fabric is with a rotary wheel. You can buy them in a craft store. See if I can find it here. It's just it's a little wheel, rotary cutter they call it. So I bought some West Systems the other day, and I never messed with it because it didn't have a high enough temperature as far as once it's cured. Sort of on the low side, developed for boats. So if you look at the spec sheet, don't worry about what you see on the internet. There's a lot of misinformation on the message boards, but if you look at the spec sheet from the West Systems, the actual published specs on it, a 105 and a 209 slow hardener, you're looking about probably max 140 degree temperature as far as what it will take before it'll start to distort. Whereas all the other stuff I've used before, you're getting up around at least 200, 250 with a post-cure 3 or 350. I bought this West Systems to satisfy my curiosity, mainly to try different hardeners with it. So I've done some experiments on some of this stuff, and it was pretty successful. What I did with West Systems, I took the 105 resin, which the 105 resin, it's either by weight or volume. So it's 5-to-1 with these pumps. So if you hit one stroke here and one stroke there with the hardener, basically you're getting 5 times as much resin as your hardener. It's pretty measured in the pumps. So that's by weight or volume. So that tells me if it's by weight, that's 20%. 5-to-1 weight or 5-to-1 volume. So what's sort of neat about this whole thing, if you go with this extra slow hardener, it has a different size pump. It's 3-to-1, so 1 part resin, 1 stroke resin, 1 stroke of the 209 extra slow. and that's 30%. So it's 3 to 1, or 33.3%, 3 to 1. And what's sort of neat about this is 33%, this HT386 curing agent. Now, this is pretty fast in the EPON 815. So, extra slow at, let's just say 33% instead of 33.3. 33% high temp with the 105 is what I'm thinking. Now, I did some experimenting where I took this right here, the 105 resin, and I mixed the 1063 right here to the West Systems at 24%, which is the ratio you use on the HTR 250. And I just grab a scrap piece of carbon just to see basically if it would even cure at room temp. So it came out like a steel shard. I mean, it came out really good. So that's 24% in the 1063 in the West Systems. I'm not sure what kind of heat this will take. I'll have to make up a unscientific method of testing it, but it's encouraging anyway. So you're thinking, okay, why do you have to, keep messing with all this different stuff? But it's sort of fun to experiment to see what's going on. Now the West Systems, the other reason I bought it, so when I was making these molds, I just wanted a really quick, simple, thin mold that would to do small parts, and I wasn't worried about heat curing. So these two sets, these two and these two match. They're the exact same wheel pant. This wheel pant mold is made out of HTR 250, and it's got a filler. It's called a DTO 81 out of Freeman. And it's got some glass cloth between the surface coat, which is a 302 surface coat. It's a gray, high temp. And the 081 filler in the middle, and it's got some glass cloth on the outside, so it's a sandwich core. This was the West Systems. It was the high temp tooling coat, which is the 302. But then I backed it up with West Systems because it was quick and easy. And the only reason I use the high temp surface coat with the low temp resin is because that's what I had. So anyway, it's sort of like a big science fair project. You come through here and you experiment on different things to see what works. It's but it's promising to know that this resin here can be formulated with a high temp hardener, and all of a sudden you take a really decent high grade room temp resin to a really good high temp resin. So it's sort of encouraging. The other neat thing, if this pump is 3 to 1, technically you could take this pump and put it with this resin. You could get high temp resin with the pumper thing, and then you wouldn't have to actually measure all your weights to mix them on a scale. So that's sort of encouraging. It just gives you more versatility. The more things you can sort of mess with and change and still maintain a really good property, I'm all for it. So this thing here, these little wheel pants, I'm not sure if I got enough of this cut, but what I was going to do is 2 layers of this stuff here. I made this little part here. This little part was a little fuselage pod. It's out of this cloth. The fuselage pod is 2 layers. I came up short a little bit in the seams. It's just 1 layer, but I'll put another seam coat in here. So this is about what I want for the wheel pant for the my stunner I'm getting ready to make or finish. These wheel pants back here are out of the same mold. but these wheel pants were made with a heavier cloth and 2 layers, so they're too heavy for a control line airplane, a stunner, but they'd be good on an RC field to bang around. They're a lot heavier, and that's what they're going to be used for. Let's see what else. It's time to, I'm going to cut this up. So what I'm cutting this on, this is a UHMW board right here. Ultra high molecular weight. And it doesn't dull your blades like glass would. Gives you a really good cut. So let me put this camera on a stand here. So I guess I'm going to need 8 of these little pieces. And then two layers of this cloth in here. I'll probably make 3 layers right around where the axle goes. So I'll have a little left over to do hopefully the seam on that fuse pod. And if you wanted to be really thrifty on your glass cloth, you could make up a pattern to cut this for, cut that from. That way you're not wasting glass, but I don't make enough of these parts to worry about it. So I just wing it. Whatever looks about right. Now I'm going to cut some of this in smaller strips. That way I can actually get the seam material for the fuse pod. It'll be distorted by the time I actually put it in there, but it'll be close enough. This stuff is so thin, it's easy to distort it. Hopefully later today I'll get my canopy on my airplane. I got to do that. So all this stuff I'm doing now, it's been done, I don't know, seems like a million times. You get on the internet, this stuff is nothing new. One of the things I haven't been able to find on the internet or anybody doing any work is with curing agents, you know, with different resins. And it's probably one of these things where it's not going to actually pay off to do it, but it's still something I wanted to try. Here's the beauty of this West system, and I'm going to check it. I was always curious to see how accurate these pumps were. So what we're going to do, we're going to mix a batch of this stuff up out of these pumps. I'll go with the slow hardener, which seems pretty quick for slow as I am. I'm going to mix this on a gram scale through these metering pumps and see how close they are. Let's see. And obviously, if you're using this stuff and all of a sudden you notice that the air bubbles coming out instead of the resin, you know that it's not right. That'd be pretty obvious. Zero my scale out. Okay. I'm going to mix it in a cup. I think this is 12.5 grams, if I remember right. Nope. This cup is, it's 1 cup in it. Different lot numbers, you probably have to weigh each cup or each batch. Okay, this is 10.5 grams. So what they're saying is this is one of these. So let's see, that was cup and the resin is 31.5. So that means I just put 21 grams in there. 20, 30 to 21 grams. Yep. I've got 21 grams of resin in there. So it'd be interesting over time. Keep measuring that to see if it's still on 21 grams. Okay, so 21 grams. I've got 31.5. Now let's see what I get with this curing agent and see if it's 20% by weight. Let's see, now I'm up to let's see, it's 35.1. No, 35 grams. Okay, cup, resin, hardener, total of 35 grams. So 21 grams of resin. Let me get my calculator here. Plus 20%. Be 5.2. See, let me see here. 21 plus 20%. Be 4.2 grams on that hardener. 4.2 grams. Let's see, 21. 31.5. 35 minus 3.5. So I've got 3.5 grams of hardener in there, and I needed 4.2. So when I hit that pump on that hardener can, it seemed like some air bubbles came out of it. 21. Do this again to make sure. 25. Okay, I need 4.2 grams to get to 20%. Let me double check this because I'm pretty sure that pump just gave me 3.5 grams. So let's see, 21. And I'm at 35. Yep, 3.5. So I'm basically a gram short. Now it's probably not that big a deal. It's still in specs, but I was always wondering about that because it's like it had an air bubble in it. I'm sure people have checked that before. So what I'm going to do here, I'm just going to add about a gram to it. 3.5, 4.2. I'm going to add, I don't know, 0.8 maybe. And that's not that much. I guess if you were using a lot of this resin, where you had like 8 or 10 different pumps on it, let's just put a tad more in there. And that's 0.8. All right, so we're where we need to be. That answers that question. You know, if you're mixing up a quart of this stuff, it's probably not super critical, but I'll tell you what, if you're making small parts and you only need 10 grams of resin and it's got to be right, I'd say the gram scale. So the pumps still make it easier for dispensing this stuff, that's for sure. Now, one of the things I'm going to do with this resin is I'm going to pour some in another cup and I'm going to add some thickening agent to it. And that thickening agent is going to go in the corner of this wheel pant where it's got a really sharp corner in there. It's got to be filled up with some Cavasil or resin. Once you lay up a couple parts, you're going to find out really quick where the little spots are that you're going to have to give special attention to. Sometimes you can, if you do enough of it, you can look at the part and you can tell exactly where the problem areas are going to be, but you lay up a couple parts, it'll rear its head pretty quick. Yeah, this friend of mine, he's made a lot of stuff out of West Systems. RC guy. Name's Larry. And he might have known about the shorting of the resin, or maybe he's done enough of it to know that what he said he'd give the hardener a shot, and then he'd come back and just a little bit, he'd tap it just to get a little bit more in there. Okay, so now I need to make some of this resin a little bit thicker. And I'm just going to pour a little bit in a cup here. Let's see what Robert said. Yes, he said, okay, Robert said sometimes the pumps drain back. I know they don't think they do, but they do, and you get air. Okay. Robert also said a digital scale so you can zero it, which is good. I got the old triple beam, which obviously you could tell it was a pain. So I think if I can get a really good beam, or not a beam scale, but electric scale that is really accurate, I'll probably get it just for that reason, just get the tear weight in there. And I'll tell you, I've mixed enough of this stuff to tell you that I've screwed up before and didn't compensate for the cup or the tear. So this is Cabosil, and what this does is thickens the resin, turns it turns it into a, well, it'll turn it into peanut butter consistency if you keep going with it. And these guys that have done this stuff before, they know what it is. There's all these different fillers you can put in these resins. Cabosil, cotton flocks. You could probably even go out and get play sand at the store, mix in to make your casting resin. So now if I mix this a little thick, I'm not too worried because I'm just going to go ahead and add more resin to it. What's going on in there? So that's about how thick I want it. So I'll take the thickened Cabosil resin, and this is the spot that I was going to fill up right here. So that's the only spot in the part that needs attention. So this cloth, about 2 ounces, I think, it conforms really well, so shouldn't be any problem. Normally when I do this, I'll go through a mold and I'll actually do all this ahead of time and let it sort of de-stage or cure. So when I lay up these parts, I just got to be careful I don't distort this area of the mold. Alright. And sometimes it's beneficial to let this sit for a minute or so, let the air come out of it. And I've done this before, and I gel coat the mold and let it cure, or B-stage. And that way you're guaranteed pretty much of not getting a bubble. Now with these wheel pants, I'm going to try to lay them up light as I can without the vacuum bag or hand laying them. So this weave, it's pretty tight. It's super conformable. And then back here, I just got to make sure that I don't wash that cabosil out of there. I've got a batch of these brushes that seem like they're shedding really bad, even if I crimp them. So that was good information that Robert gave me about draining back in there. So the pump that the resin was in, didn't have any trouble with that because the resin is thicker. Now the curing agent, it's a little bit thinner, I think, so it probably is a bad deal with the drain back. Yeah, the sandblasting. I don't have a sandblaster, Robert, but I got a friend that he's got a, I don't know what you call it. It's got the water with it. So I've taken stuff over to his house and had him blast them for me. Just out of curiosity, I wondered what you'd use a good scale for in a sandblasting operation. It would be something I wouldn't think you'd use, unless you'd weigh out the medium. So I don't do a lot of glass work as far as fuselages, and well, I've never done a fuselage before. Most of the composite work I've done has been parts like bell cranks and landing gear. So a lot of this stuff, well, I've done wheel pants, but I don't have as good an eye as most people on exactly what I need as far as the cloth. Some people could look at a part, tell you exactly what cloth to put in there, what order it goes in and everything. I've got to experiment a little bit. I've got to make a few parts to see how it's all going to work before I get what I want. Now I had a little bit too much glass in here, and then I added another layer, and that pretty much sopped up the extra resin that I had in there. You get that brush here out of there. It's always something there. So 2 layers looks about right. Now when you lay this up, you can see where the glass is wet. It should disappear once you get it wet out. Now I was making these heavier pants out of a thicker cloth, and I had a hard time getting it to lay down, and even in this area here, but this stuff here looks like it conforms really well. That's pretty much where I want it. I don't want to see any pooling. It's alright, I guess, on these. If it's a little glossy, I don't expect it to be dry looking. But what you don't want is you don't want resin pooling up on top of the glass. I do know that. So in this West Systems with the slow hardener, it acts pretty much like the resin services I've used. It's got the same feel to it. Got a different smell. Doesn't have the stink like the other stuff does. And the reason why I'm probably messing around with these wheel pants, obviously I need them from a plane. The stunner I'm getting ready to work on here and finish, but The real reason is to actually figure out how I'm going to make some fuselage plugs and molds. Once I get the resin figured out, the process, then I got to go figure out how I'm going to split it, where the parting lines are going to be, the hatches, and all the other stuff. Now there's ways to actually go back after you make a part, take a splash off a certain area, which is make a mold off of part of your part. A splash mold they call it. And you can sort of reverse engineer some of that stuff. But I'm going to try to stay away from that if I can help it. So I can tell right now this resin's getting a little bit thicker. And obviously this is real time. And if I get to the point where I feel like I'm compromising the part, you know, I'll go ahead and mix up another batch. I won't try to force this into a mold just to use it up. I might get one more half out of this resin in this cup. Wet blast, yeah, wet blaster, yeah. Okay, he weighs out the paint. Okay, yeah, that makes sense. Yeah, the vapor blaster or wet blaster, he's got one of those, my buddy. I'll tell you what, it comes out silky smooth. I don't know, it's got a property that's less aggressive, I think. It depends on the medium. And I know from talking to him, you can get some money in that medium. You could, when you get into some of this exotic blasting medium. He bought it to do some car parts. He was working on a Porsche. And that's what he got it for. It's an industrial thing. It's a big old cabinet. You had to get a really big compressor to run it. That was part of the battle right there, the CFM. Now, this mold is pretty crude as far as the engineering on it. Obviously, the part comes out and I got to trim it. The thing I didn't like about in the mold parts where you put the clamshell together, you don't know what you've got. You can't see it, if it's coming loose or not on the corners and the sides. And the other thing is, it takes more work on the mold. You've got to actually do the geometry, and you got to do a little bit more work on the mold to get it to work right. So this resin got a little thicker, but it's holding out. Now, any of you guys watching that have done composites, you'll know that if you want to extend the life of this resin, you get it out of the cup, and then you lay it out on a plastic plate or something to where it's not in a mass. So this is just a little bit in a cup, but if I had a full cup where it was all the way almost to the top, then it might be beneficial to get it out of the mass of the cup and get it laying on a plate spread out so it wouldn't heat up as much. So heating epoxy up, even now at this stage, will make it thinner. But what happens once you get past the thin stage, it speeds up the cure of it really fast, so it'll kick quicker. There's a couple parts I was making, one of them being the landing gear, and then the other the bell crank. And what I was thinking of doing is building a heated mold. So I'd plug the mold in. It'd be like a coffee warmer. You know these little plates you set coffee cups on to stay hot? that kind of technology. It would be, the heater would be built into the mold. And I'm not talking super hot. I'm only talking like 150, 60 degrees. And once I had the heated mold, then the resin would actually flow better. It would kick off quicker, but it would speed up the process and give you a better part. And another thing you might have noticed with me on this wheel pan here, it saves time to have all your stuff cut. Don't start mixing the glue until you have all your glass cloth or carbon or whatever you need all cut up. So I can tell the way this is working now. It's still wetting out, but it's wetting at a slower rate. And right now I'm sort of playing beat the clock. So if I don't get this extra pad in there for the axle, give it a little bit more support, I can always go back afterwards and another batch of glue, I can glue another one in. To get the really good adhesion on composite parts, if you get the second coat, the second layer or whatever you got going in there before this fully cures, so in other words it's just a little soft, they call it B stage, I think is what they call it, to where it's starting to get rubbery but it still doesn't leave a fingerprint maybe. And that's a good time to actually go back with another layer. But I can imagine if you're not interested in this stuff, even if you are, if you're watching this video, it would remind me of watching golf on a Sunday. You know, where you're laying on the couch and you're falling asleep. That's what composites are to me. It's like watching golf. Sort of fun to do. Fun part is coming out and opening these molds and seeing what you got for the, especially when you try something new for the first time. You don't know what's going to happen. So this weave, it's sort of got a satiny weave. I don't know how to explain it. I got to get some more of it, but I'm not sure what it's called. Yeah, I'm wasting a lot of cloth here, but by cutting the extra off that comes over the top of the mold, it keeps it from falling over and pulling it out of the mold, especially as light as this stuff is. It'll stay in the mold. Let's put a little bit extra in there for the next layer of cloth. Looks like my cabasill's holding up pretty good in the corner. So they've got carbon out that's 1K. I don't know if they still have it in stock in some of these places, but it was super light, super expensive. Normally carbon I think is 5K. And when I say 1K, it's the size of the toe. So the 5K carbon, which is on a bigger scale, that's usually pretty light stuff. So you can imagine the 1K. Not many people out there in industry were using it. Yeah, the resin services curing agent with the West systems, that was pretty promising. You're better off using what comes with the curing agent as a kit, or what they recommend. But one of the parts I was making was a bell crank. It was a really small part, and I've made them at a HTR 250, just 106.3, just the normal resin hardener. And I've made some really good parts, and there was nothing wrong with them. They're great. They're high temp, and they work really well. But the drawback to that combination was the viscosity of the resin. So if you make a really small part, sometimes, well, most of the time, it's beneficial to get a really thin resin. And this was the early 90s, so they weren't doing a lot of resin transfer molding, or VARTEM, or vacuum assisted resin transfer molding. And they're doing more of that today, so they have really thin viscosity resins out now that you use for vacuum assist, RTM. There's a lot of different acronyms for it. But back then, I had to come up with a resin that was thinner viscosity, get around 700-800 centipoise, to actually make the part quicker and easier to make without losing any properties. And that's why I had to go with EPON 815 and this HT386. So in effect, I wasn't using an EPON curing agent, or one that was labeled as such. I was using resin services. So today, you could probably get to a place and say, hey, give me a high temp RTM resin transfer molding, VARTEM, whatever you call it. Give me some of that, and you'd be good to go. So this little pad I'm putting in here, I'm going to come in here right where the axle goes and just put a little bit more in here. I'm not going to add any more resin. It was a little resin rich there anyway. So this will give a little bit more stability right there where the axle is. It's just a little touch that helps. You got to remember, you look at these wheel pants, it's not real obvious where the top and the bottom is. They're pretty symmetrical. The bottom's a little bit more squared off. So you got to make sure you get the pad on the bottom of the pant where the axle is. And that's one of the beauties of composites, and being able to actually adjust where the strength is, the stress points. You can take a point in the mold or the part that has a stress riser, and you can flare it out, distribute the load farther out by extending the cloth or your reinforcement. And you can sort of tailor make your layup to suit the properties of your part. Now see, it's got a sort of a gloss to it, but it's not puddled up, and that's what I was looking for. Got to wet the pad out a little bit. So let's just say that I make a couple of these wheel pants and I find out that it's still a little weak in this axle area, or it might have stress cracks or whatever. I can go back and I can add another layer of this cloth, or I can add another layer that's thicker, or I could go back and put a patch of carbon in there or Kevlar or whatever. So I'm going to try to get these pretty good, that way these are going to go on my stunt plane. Another tip you can do on some of this stuff when you lay it up, and it's not too bad with this fabric here, it's pretty tight. But let's just say that you have a sort of a loose weave fabric. You can take it and you can pull it diagonal like that, and what happens then, it tightens the weave up like a Chinese finger puzzle. So that way you can, especially on small parts, you can achieve a tighter weave. So that sometimes helps. So you can take a relatively coarse cloth and make it fine if you want for, you know, small parts. Obviously you don't want to do that on something huge, but the big stuff like car hoods and things like that, when they make them, they'll run little tracers through there, and that way you can keep it all straight sometimes. You know where you're at, especially if it's going to be a cosmetic part with no paint on it. So I do one last thing. I go around the edge and I look at the whole perimeter and make sure that it's up in the mold. Make sure it's stuck down good. And there's a little spot right there, a little dry. Put a little bit more resin right there. And also I might come back, trim off a little bit extra it's hanging. Stipple down little problem areas. And I got a little hot box here that these parts go in, and usually keep it about 100 degrees. Now, one of the things, I think I'm on, let's see here. Yeah, 1,200 CFM. Wow, that's a lot. Yeah, mix too much. Yeah, some of this resin, you might think you have so much open time on the resin, so you go back the next day with the same hardener, the same temperature, the same everything, and all of a sudden it's curing off quicker. It's because of the mass of resin that's in your cup. So you got to take that into consideration. So there we go. That's how long it took somebody that's really slow to make 4 halves, which would be 1 pair. So it takes a while, at least for me. But yeah, the cavasil for the corners, stuff like that. Now, one of the things I'll do here, I'm going to mix up 33% per hundredweight of this 386 in this West Systems. Let me get rid of this cup. I'm done with this. Let's see how close this this West System stuck to 21 grams. Should have weighed the cup, but It's the same cup as out of the same batch, so I'm just going to assume it's 10.5. So let's see where we're at. So the last cup and squirt was 21. Let's see, 10, it's 31.5. 31.5. So okay, 31.5. So yeah, it was consistent with the first batch. So 21 resin. Let's see what we get here. Plus 33% with this. 33%. 27.93. Add the cup back in. 38.4. 38.43. So we'll just say 38.4. So let's see here. See if I can find a HTR 386. Let me clear this opening up here. Be right back here. So this little opening is so small I have to use a strand of a lead out wire to open it up. It's going to take too long, it's clogged up. Let's see here. Let's uncap it. So HTR 386 and West Systems. That's just what I needed. So this is an experiment we won't know the results of because obviously it's not going to cure in order for this video to finish, but we'll get an idea of what it looks like. And then also I'll probably do a short film or a short video with the results of this. Let's see here. Get back to my screen. Okay, Robert. So he's got to get back to work. So I don't have anything laid up or ready to lay up. So what I've got to do here is just find some scrap cloth, get some carbon fiber, wet it out and see where I'm at. This was old curing agent. Turns a little amber. and it's been in that little bottle a while, so it'll have a little bit of discoloration in it. So I'll grab some of this cloth and see what we can get out of it.